Hello, this is Mr. McNair, and this is a short review on solving linear systems by graphing. I think that you might want to pause and read this real quick just so that you have an idea of how to work these videos. Linear system. A linear system is two or more linear equations working together. Just like there's systems in the body, like the digestive systems and the nervous systems, and those systems are a bunch of organs that work together to perform a certain function. That's the same thing with a linear system. It's two or more linear equations working together. Now, the solution of a linear system is an ordered pair that works in all of the equations. So, for example, here is a linear system. It's two equations that are working together. Now, the question says, is the given ordered pair a solution to the system? Well, here's my ordered pair, 0, 6, and we know that every ordered pair is both an x and a y. Now, the definition of a solution to a linear system is it's an ordered pair that works in both equations. So I have to make sure that this ordered pair works in the top and bottom equation. So let's work with the top equation first. X plus 4y equals 24. Now, we know that x is 0 and that y is 6. So we're going to plug those into their corresponding places. 0 for x and then 6 for y. So 4 times y is 6. And we want to know, does that equal 24? Well, if I calculate that out, 4 times 6 is 24. Is 0 plus 24 equal to 24? Yes. So it works in that equation. Well, we're not done though, because it has to work in both. So let's plug it into the next equation. Negative x plus 2y equals 6. Now, some people don't read that negative x. They might say the opposite of x, because technically you read the opposite of a variable instead of the negative variable. So let's plug the opposite of x plus 2y equals 6. Let's plug in 0 and 6 for those numbers. So the opposite of 0 is 0, plus 2y, y is 6 still. We want to know, does that equal 6? Well, 2 times 6 is 12. Is 0 plus 12 equal to 6? No. So is 0, 6 a solution to this linear system? No, it's not, because it didn't work. That ordered pair didn't work in both equations. Now, here we go. Same system, different ordered pair. This time we're going to use the ordered pair 4, 5. Once again, x is the first number in the ordered pair, y is the second. Remember, ordered pairs always go x, then y, or you can look at it as going in alphabetical order. So, again, we're going to take our first equation, x plus 4y equals 24, and we're going to plug in x and y for the variables. So 4 plus 4 times 5. We want to know, does that equal 24? Well, 4 times 5 is what? That's 20. Is 4 plus 20 equal to 24? Yes, it is. Now, we're not done, once again, because we have to plug it into both equations. So we have negative x plus 2y equals 6. So here, the opposite of x, and x is 4, so the opposite of 4 is negative 4, plus 2 times y, y is 5. We want to know, does that equal 6? Well, what's 2 times 5? 2 times 5 is 10. Is negative 4 plus 10 equal to 6? Yes, it is. Now we notice that this time the ordered pair worked in both equations, so this ordered pair is a solution to the system. Alright, let's move on. Now when graphing, the solution to a system is always where the two lines intersect. So for example, here it says use the graph to solve the system. Well, I actually graphed the two lines already. Here's the system of equations, and I graphed both of those lines. And we see that those two lines intersect where? At this point. So what's the solution to the system? Well, the x of that point is 2, and the y is negative 1. So the ordered pair, that's the solution, is 2, negative 1. Now, you should always, always, always check your answer when you're solving a linear system. And here's my check down here. If you need to make sure that you could do that correctly, you might want to pause the video and go through that. Now, here, I gave you a linear system, but I didn't graph it. So what do you think you have to do? Right, exactly. You have to graph it yourself. So let's take a look at these equations. Let's look at the first one. What you're going to do when you're solving a system by graphing is simply graph each of those lines separately and then see where those two lines cross or intersect. Now this first line, is it in slope-intercept form? Yes. Slope-intercept form, just for review, is y equals mx plus b. Okay? So, you know an equation is in slope-intercept form if the y is by itself. Here, the y is by itself. So, let's deal with the y-intercept. What is the y-intercept? B stands for y-intercept, and that's -3 here. What's the slope? The slope is the number in front of the x, and here, that's 1. The coefficient is 1. So the slope is 1. Now, because we're graphing, we want to use slope as a fraction, because slope is rise over run. So we're going to do 1 over 1. So that we know that when we're doing our movement from one point to the next, we have to go up 1 over 1. So first thing we're going to do is plot our y-intercept. Always plot your y-intercept first. And the y-intercept is always plotted on the y-axis. So the y-intercept is -3. And from that -3, our movement is going to be, based on our slope, up 1, right 1. Up 1, right 1. Up 1, right 1. And when you make more points, you always go from a previous point. Okay? Now, other movements that we could have made besides up 1, right 1 is also down 1, left 1. Down 1, left 1. Okay? Because 1 over 1 is the same thing as -1 over -1. Why? Because a negative over a negative is also a positive. After that, you're going to go ahead and just connect your dots with a straight line. Some math teachers don't like the phrase straight line simply because every line by definition is straight. There's no such thing as a curvy line, so straight line is kind of redundant. But I say it sometimes just because of habit. Now, the second line, or second equation, is that in slope-intercept form? Yes. How do you know? Because y is by itself. So what's the y-intercept? -1. What's the slope? That's also -1. Now once again, because we're going to be graphing, we want to probably put that as a fraction. So that's going to be -1 over 1. So that we can do our rise over our run. So the y-intercept is -1. And the slope is -1 over 1. So we're going down 1, right 1. Down 1, right 1. Down 1, right 1. And once again, we went down 1, right 1 because it was negative on the top. So how do you rise -1? By going down. It was +1 on the bottom. So how do we run +1? We go to the right. Now, besides going down 1, right 1, what other movements could we have made? Up 1, left 1. Good. Up 1, left 1. Up 1, left 1. And the reason why we could have made those movements is because -1 over 1 is the same thing as +1 over -1. Okay? If you type these in your calculator, both of these will come out to be -1. So once again, we connect the dots with the redundant straight line. And we see that these two lines intersect at the point here. And what is that point? 1 for x, -2 for y. Alright, and there you go. You're done with that problem, except for the fact that you should check. And it actually says check in the directions. Every problem you should check. Here's the check to this problem. If you want to, you can go ahead and pause the video and make sure that you know how to do that accurately. This problem here is a little bit more complex because if you look at this first equation, is it in slope-intercept form? No. How do you know? Because y is not by itself. How do you get y by itself? Well, you have to subtract x from both sides, right? So the x's on the left cancel out, leaving you with y. On the right, that leaves you with -x minus 2. Is it in slope-intercept form now? Yeah, because the y is by itself on the left. What's the y-intercept? -2. What's the slope? -1. But once again, we want our slope to be a fraction, so we're going to write that as -1 over 1. So here we're going to graph -2 as our y-intercept, so we put that on the y-axis. And from that -2, we're going to graph our slope by doing a down 1, right 1 movement. Down 1, right 1. Down 1, right 1. Or we could have also did, good, up 1, left 1. Up 1, left 1. Up 1, left 1. And once again, I'm going to keep on making points because you never know where the two lines are going to intersect. Because lines can intersect in the darndest places, right? Alright, so there's our first line. Let's go ahead. I'm going to erase this here so that I can start doing the work for the second line. So here we have 2x minus 3y equals negative 9. Is this equation in slope-intercept form? No. How do you know? Because y is not by itself. What's keeping y from being alone? The 2x and the negative 3. Which one do I get rid of first? The 2x. How do I get rid of a positive 2x like that? By subtracting 2x. And whatever you do to one side, you have to do to the other. So those cancel out, leaving you with negative 3y equals, on the right, negative 2x and a minus 9. Is y by itself yet? No. What's keeping y from being alone? The negative 3. It's connected through multiplication. Inverse of multiplication is division. So we get y equals negative 2 over negative 3, and negative over a negative makes a positive. So that's positive 2/3 x. And again, a negative over a negative makes a positive. So negative 9 divided by negative 3 is positive 3. So we see that the y-intercept is 3, and the slope is 2/3. So we have a y-intercept of positive 3, and our slope is 2/3. So from that 3, we're going to go up 2, right 3. 1, 2, 3, up 2, right 3, 1, 2, 3. Or we could have also went how? Down 2, left 3, 1, 2, 3. Down 2, left 3, 1, 2, 3. And then we connect our lines again, or excuse me, our dots again with a straight line. And once again, we see that our lines intersect, and they intersect at this point here, which is the ordered pair, negative 3 for x, positive 1 for y. And then every y student at the end of this problem would do what? Check. All right, so you might want to go ahead and pause the video and check that problem again. This last example is relatively simple as long as you realize that every time you have x equals a number, it's a vertical line, and every time you have y equals a number, it's a horizontal line. So x equals 3 is the vertical line through x equals 3. So there's the vertical line through x equals 3. And y equals negative 5, that's the horizontal line through y equals negative 5 on the y-axis. All right? And we see that these two lines intersect at what point? 3 for x, negative 5 for y. Now, does that make sense? Well, hopefully it does, because at the beginning I told you that x equals 3 and that y had to equal negative 5. So that would be our solution. All right, I hope that this helps, and good luck with solving linear systems by graphing.